This here is a visualization of the Linux kernel. The Linux kernel is tens of millions of lines of code, and attempting to understand such a vast code base with traditional tools like text editors and file explorers is a bit like trying to map a mountain with a magnifying glass. It's really not the right tool for the job, and so at the American Compute Company, I've been working on this experimental tool called Astrolabe, which is attempting to find some new ideas about how we can understand such large code bases. So this visualization here, we can zoom in, we can scroll around. Every pixel here corresponds to a file, and they're colored based on their file extension. And they're also arranged somewhat chaotically, but the layout algorithm tends to keep files that are in the same directory relatively close together, and it gives you this kind of hierarchical structure. So let's mess around with this a little bit. So the Linux kernel happens to include a lot of goto statements. And we can search through here, and Astrolabe's parser happens to find 148,106 goto statements in this version of Linux. Now, granted, Astrolabe is fairly language agnostic, and the parser is not able to tell the difference between code versus comments versus documentation, but it's found almost 150,000 things that look like a goto statement. And we can mess around with this a little bit. Let's pick a color like red, and here we go. We've colored the files based on whether or not they include goto statements. And as you can see, all the files here that are colored red happen to include a goto statement. So we can save this with a name, and so now we have a map called goto, and it has 11,916 files in it. Now we can zoom in a little bit, and so this is a file in the USB driver, and we can scroll through here a bit, and we find some goto statements, and we can even see a little bit about how Linux tends to use goto statements, which is for a form of error handling. Now we can zoom out a little bit. We can click up here and go to parent directories, and that brings us into the USB driver. And let's select the USB subdirectory. And so these are all the files that are in the USB subdirectory, right? And we can save this as well. There are 849 files here. We can also now, granted, this is granted not every file that mentions USB is going to be in this directory, and so we can also go based on path. And so here are all of the files across the entire Linux code base that happen to include USB somewhere in their path. And so we can save this as USB path, and that's 2,278 files. Now let's clear this, and let's look around at some other things. So let's look at AMD GPU. So this is all. So here we have all the files. There's not too many of them that happen to be part of the AMD graphics drivers, and so we can save this, and this is 437 files, and we can look around here and look at some of these files. We see a lot of references to AMD GPU stuff, but we can also zoom out a little bit. We could look at the GPU drivers, and let's pick a different color for that. Let's rename it to GPU, and get this subdirectory. And so here we have all of the GPU drivers, and we can also look at the GPU and AMD GPU drivers at the same time. So here's AMD GPU, here's all of the GPU drivers, right? And we can also go in here and we can just look at drivers in general. Let's pick that, and here. So this is across the entire Linux code base, this gigantic thing is just all of the driver code. And so we can save that, and so we can, and here we can see we have all of the driver code, we have all of the GPU driver code specifically, and we can see all of the AMD GPU driver and code, and we can click around this and look at various files in here, and look at all of the different files and directories in here, and so this is a nice tool for getting some basic large-scale insights into a code base. And I think in general, people spend more time reading code and debugging code than they spend writing it. And we have a lot of tools being developed right now with AI stuff around being able to write code faster, but oftentimes being able to understand code better is somewhat neglected. Yes, you can ask LLMs this kind of stuff, but there are things there are better tools than just text queries in a lot of cases. And in general, I think that as we face more and more AI tools, we shouldn't be trying to make humans obsolete, but instead we should be trying to push the limits of what humans can do, and by building better tools for doing so. And so this is just one small step in that kind of direction. And you can find this tool at uscompco.com.